Generative AI. It's literally the biggest buzzword of the decade, right? But what is actually happening behind that chat window? Today, in this explainer, we're cutting through the hype. Using technical insights from IBM and Google's recent product updates, we're going to tear down the engine, see exactly how it works, and explore how it's fundamentally reshaping our digital reality. So, here is the provocative question driving our explainer today. How is this underlying tech completely destroying the era of 10 blue links? We all know traditional search is kind of dying out. To understand what's replacing it, we really need to look at the engine powering this massive shift. Here's our roadmap for today. 1. What is generative AI? 2. The engine under the hood. 3. Supercharging Google search. 4. Beyond chatbots, AI agents. And finally, 5. The risks and reality. Let's get right into it.
All right, section 1. What exactly is generative AI?
It's super tempting to think this tech just magically appeared out of thin air with ChatGPT in 2022, but IBM's data reveals a totally different and, frankly, surprising timeline. This evolution actually started way back in 1964 with the ELIZA chatbot's basic pattern matching. It took decades of grinding, working through GANs and diffusion models around 2014, and then hitting the massive transformer breakthrough in 2017 to finally reach the explosion we're all seeing today. Distilling IBM's insights, the absolute core differentiator of Gen AI is autonomy. These aren't just your standard retrieval systems, they're deep learning algorithms that actually simulate human cognitive processes. They encode patterns from massive datasets to autonomously generate entirely original text, images, or even code, all based on your prompt.
Moving right along to section 2, the engine under the hood.
So how does this engine actually work? According to IBM, the whole operation breaks down into 3 logical phases. First up is training, where a foundation model basically eats terabytes of raw, unstructured data. The second phase is tuning, where developers tailor that massive model for really specific tasks, using labeled data or human feedback. And the third phase is generation and evaluation, where the model's outputs are continually assessed and retuned to boost accuracy. Think of a foundation model kind of like a brilliant but, totally unfocused generalist. It knows a little bit about everything. But to make it truly useful, say turning it into a highly accurate customer service rep, it needs fine-tuning. You have to funnel in specific labeled data so it graduates from being a generalist to a specialized expert. Now, the absolute secret sauce powering these foundation models is the transformer architecture. Introduced in a landmark 2017 paper, transformers completely revolutionized AI using something called attention. Instead of reading word by word like older models, they process entire sequences simultaneously to capture deep context. That right there is the secret behind their astonishing natural language abilities. But wait, there's a catch. These models are essentially frozen in time. They're only as smart as their static training data. The workaround? It's called RAG, or Retrieval Augmented Generation. RAG allows the model to actually reach out to live external sources. Think today's weather or current stock prices, guaranteeing its answers aren't just smart, but actually up to date. Okay, section 3, supercharging Google search. Let's bring this into the real world. Think about planning a family trip. You used to have to do 3 or 4 separate searches, kid-friendly parks, dog-friendly parks, and then manually comparing Bryce Canyon to Arches. Now, with Google's Search Generative Experience, you just ask the whole multi-park constraint at once. You just type, what's better for a family with kids under 3 and a dog, Bryce, or Arches? As Google themselves highlight, the AI provides a comprehensive snapshot of key information right at the top of the page. It cross-references all those specific constraints you gave it, the toddlers, the dogs, the multiple locations, and gives you a synthesized answer, along with suggested next steps and links to dig deeper. It's basically doing all that tedious synthesis work on your behalf. Now, this gets truly mind-bending when you look at the scale, especially in shopping. The AI isn't just guessing here. It's pinging Google's shopping graph, which is a staggering dataset of 35 billion product listings. That's billion with a B. It matches your complex constraints against the most comprehensive product database on Earth. And hey, remember what we just learned about RAG and the absolute need for fresh data? Well, Google knows this is critical for shopping. To ensure those generative results are reliable and not just showing you out-of-stock items, more than 1.8 billion of those product listings are refreshed every single hour. It is a massive, continuously updating operation.
All right, shifting gears to Section 4, Beyond Chatbots, AI Agents.
We absolutely need to clearly contrast what we've been talking about with what is coming next. Standard generative AI is essentially passive. You give it a prompt, and it creates content or answers a question based on learned patterns. But agentic AI? That's a whole different ballgame. That is a system of autonomous agents that interact with each other and with digital tools to actively accomplish complex goals, completely designing their own workflows without any human intervention. IBM has a perfect example to really illustrate this difference. Standard generative AI might draft an amazing itinerary and tell you the best time of year to climb Mount Everest. Cool, right? But agentic AI actually takes agency. It actively interacts with real travel software tools to book your flight, reserve your hotel in Nepal, and secure your permits without you having to lift a finger. It literally executes the task.
Finally, let's look at Section 5, the risks and reality.
Look, we aren't living in a perfect sci-fi utopia just yet. Both IBM and Google heavily acknowledge there are some significant hurdles. These systems can generate inconsistent outputs just depending on how you phrase a prompt. They pose massive threats to intellectual property if sensitive data gets fed into them. And as IBM points out, malicious actors are already using AI to create highly convincing, deceptive deepfakes for voice phishing scams and financial fraud. It's serious stuff.
A particularly wild everyday risk is what's known as a hallucination, because these models are essentially just high-powered, probabilistic prediction engines, literally just guessing the next most likely word. They can confidently hallucinate complete fiction. IBM actually cites a famous example where a lawyer used AI for research, and the model generated entirely fake legal cases, complete with flawless formatting and fake quotes that looked 100% credible to the user. No way, right? But it happens. Plus, we have to consider the actual data these models are built on. Because they train on vast swaths of scraped internet data, they can inadvertently learn and amplify flawed patterns or societal biases present in that raw information. For engineers, this is a major technical hurdle. It requires strict guardrails and diverse tuning data to ensure the AI's output actually remains accurate and functional for everyone. It's absolutely crucial to remember that even the most bleeding-edge systems have limitations. Google directly states this regarding their new search experience, saying, "Search, even today, will not always get it right." They are relying on decades of fine-tuned systems to evaluate these models, but it still requires a highly responsible, constantly evaluated approach. We just can't trust the output blindly. As we wrap up this explainer, I want to leave you with something to really chew on. We've seen how the internet is shifting from simply retrieving links to providing synthesized answers, and very soon, deploying autonomous generative agents to do our heavy lifting. So, as these tools become deeply embedded in our software, how will you adapt your own workflows to stay ahead? Thank you so much for exploring the mechanics of generative AI with me today, and keep questioning the technologies shaping our future.